The James Webb Space Telescope, humanity's most advanced eye on the cosmos, may have just revealed something extraordinary. Nearly 4 light-years away, on a world circling our nearest stellar neighbor, astronomers have detected mysterious glimmers of light. These faint but persistent signals appear to be radiating from Proxima Centauri b, an exoplanet long regarded as one of the most promising places to search for life. And the nature of these glows has sparked one of the most profound questions in human history. Could this be the first evidence of artificial light, a sign of an intelligent civilization beyond Earth? At first, the idea sounds more like a science fiction story than a scientific report. But the observations themselves are real. Using its infrared instruments, Webb picked up repeated light emissions coming from Proxima b's dark hemisphere, the side permanently turned away from its star. What caught astronomers' attention was not simply the presence of these emissions, but their consistency. The pulses were steady, rhythmic, and structured, unlike the chaotic flickers of auroras, lightning, or volcanic eruptions. To some, the data suggested design rather than chance. To understand the weight of this discovery, it helps to consider the planet itself. Proxima Centauri b orbits the red dwarf Proxima Centauri, the closest star to our Sun and a member of the Alpha Centauri system. At just over 4 light-years away, it sits practically next door in cosmic terms. The planet is rocky, similar in size to Earth, and lies within the so-called habitable zone, where temperatures could allow liquid water to exist. For years, it has been a prime target in the search for extraterrestrial life, but until now, the clues were only indirect. One key factor is Proxima b's rotation. Scientists believe the planet is tidally locked, meaning one hemisphere is in constant daylight while the other is locked in endless night. If life has evolved there, it would have to adapt to extreme conditions. For any intelligent species, artificial light could be not just convenient, but essential for survival on the dark side. And that is exactly where Webb's instruments recorded the faint, consistent glows, varying in intensity much like the pattern of city lights seen from orbit around Earth. Naturally, astronomers are cautious. David Kipping of Columbia University and others have pointed out that the data cannot simply be dismissed as instrument error or background noise. The patterns call for deeper investigation. And the intrigue only grows when combined with another finding: Webb's analysis of Proxima b's atmosphere. The telescope detected high concentrations of methane, but without the corresponding carbon monoxide that should appear alongside it in most natural processes. On Earth, that kind of imbalance is a strong indicator of biological or industrial activity. So what might we actually be seeing? Some theories suggest the lights resemble urban-scale illumination, the glow of settlements or power grids stretching across the night side of the planet. Others propose that the emissions could be deliberate beacons, designed to signal across interstellar space. Instead of using radio, as Earth's SETI programs have long expected, perhaps a civilization there relies on pulses of light as their means of communication. But there are even bolder possibilities. Advanced engineering could explain the signals: giant orbital reflectors illuminating the dark side, or space-based solar arrays powering subterranean cities. A society facing the constant threat of solar flares from its volatile red dwarf might need technological solutions far beyond our imagination. And yet, science demands restraint. Could natural processes still explain the mystery? Volcanic activity, glowing minerals, or heat from tectonic vents are all possibilities. But such phenomena usually create chaotic, uneven emissions, not the symmetrical, repeated patterns Webb has observed. The regularity of the signals challenges these natural explanations, making them less likely, though not impossible. Even the act of detecting these faint glimmers is a remarkable achievement in itself. Proxima Centauri, though a small red dwarf star, still outshines its planet by billions of times. To capture light from Proxima b against such overwhelming brightness is like spotting the glow of a firefly next to a lighthouse from across an ocean. Webb's coronagraph, a device designed to block out a star's blinding glare, made this possible. By masking the star's light, the telescope could isolate and reveal the faintest of signals coming from the planet itself. It's a technical triumph that not only demonstrates Webb's extraordinary power but also shows us how close we are to directly imaging other worlds. And this is just the beginning. In the coming years, a new generation of instruments will push these boundaries even further. NASA's Habitable Worlds Observatory, still in its planning stages, is being designed specifically to search for Earth-like planets and probe their atmospheres with unprecedented detail. On Earth, the extremely large telescope now under construction in Chile will use adaptive optics to correct for atmospheric distortion, giving us sharper images than ever before from the ground. Together, these tools could confirm whether the strange glow from Proxima b is truly technological, or whether nature has once again outpaced our expectations with a phenomenon we have yet to understand. But let's imagine, for just a moment, that the artificial explanation is correct. The implications are staggering. A civilization orbiting the closest star to our own, only 4.24 light-years away, would change everything we know about our place in the cosmos. They might be explorers, navigating the challenges of a volatile red dwarf star. They might be survivors, having built technology to endure relentless stellar flares. Or perhaps they are scientists, peering outward as we are, searching the skies for signs of life beyond their own world. The idea that they could be watching us, just as we are watching them, adds a layer of wonder and humility to the discovery. If the lights are real, humanity's oldest question, "Are we alone?" would finally have an answer. And the focus would shift from, "If life exists," to deeper questions. What kind of life? What are their intentions? How do they communicate? And could we ever meet them? The first confirmed glimpse of another civilization would ignite a new era of exploration, science, and philosophy, one where our sense of identity expands from being inhabitants of Earth to participants in a galactic community. Of course, science requires caution. Even if the lights are natural in origin, this discovery still transforms astronomy. It forces us to refine our instruments, test new methods, and question assumptions we've held for decades. The universe, we are learning, is not a silent void but a stage filled with unexpected phenomena. Each discovery reminds us that the cosmos is stranger and richer than we ever dared to imagine. And yet, the possibility lingers, a tantalizing what if. If these glimmers are not random, not geological, not atmospheric, but a quiet message across the cosmic sea, then perhaps we are not alone. Perhaps Proxima Centauri b is whispering, in its own way, "We are here." If that is true, then we stand at the edge of the most important discovery in human history. A discovery that would forever reshape how we see ourselves, our planet, and our place in the grand story of the universe.